Circle theorem questions. So once again, we're looking for the clues, we're looking for tangents, we're looking for clearly marked origins, we're looking for angles subtended by the same point. And in this case, we're looking for 4 points on the circumference. So one of the things we can see is we've got a tangent, so we need to be looking for tangent is perpendicular to the radius. We need to be looking for alternate segment theorem. And we've also got 4 points on the circumference, so that means we should be looking for the cyclic quadrilateral. So maybe I should write those now. There's a tangent with no radius, so the tangent is going to use the alternate segment theorem. And then we've got 4 points. I know you're loving the handwriting, so we're going to look for cyclic quadrilaterals. Right, let's start with ACD. Now, when you find an angle ACD, what can we use? Well, let's take a look at our options here. We can use the alternate segment theorem to fill in some angles. So if that's 54, then we know that this is 54. And oh yeah, that's the angle we're looking for. Sorry. So alternate segment theorem. Sorry, I always have to look at circle theorem questions before I get it. This angle is the same as this one because of the alternate segment theorem. It says the angle between tangent and a chord, that's AD here, is the same as the angle that the chord subtends at the circumference. So if we look at the angle AD makes at the circumference, that's 54. So very simply, 54 degrees, alt seg third. I'll write out alternate segment theorem. If we really wanted to make sure that we got the mark, we'd say PAD equals ACD. But just angle alternate segment theorem is probably enough. Explain why BD is a diameter of the circle. What properties do diameters have? The key circle theorem property of the diameter is that the angle subtended by a diameter is 90 degrees. Now BD is not drawn on there, so it might be useful to draw it on there. I'm going to use the straight line tool for this. Go. Still didn't get to me. Never mind. Now, diameter makes 90 degrees. Can we see 90 degrees? No. What do we do? Aha! Slightly cunning. The angle subtended by BD is either this one down here, and we'd have to prove that's 90 degrees, and we could do that, but it would take a while. Or we could look at this one here. Now, if that's 90 degrees, it's a diameter. What's 54 plus 36? Oh, it's 90. Excellent. So, DCB equals 90 degrees, and diameter, that says diagonenter, it should say diameter, depends, right angle. I know that's awful to read, but I think you understood what I was trying to say. Work out the size of angle ABC. Okay, to work out ABC, that's the angle subtended by chord AC. How are we going to work out chord AC? Well, there's two ways of doing it. We could use the alternate segment theorem. We can use that and that to work out this, and then we can do 180 minus that is this, and that would be the same as B. Or we can use these 2 points that we wrote down at the start. If you see a tangent, good chance there's all segment theorem. If you see 4 points, cyclic quadrilateral. ABC is opposite CDA, and we know that when you have opposite angles in a cyclic quadrilateral, they add to 180. So very simply, the answer to this is 102, and the reason is that opposite angles in a cyclic quadrilateral add to 180. Let's see how well I go at writing this. It's pretty bad. Cyclid, quadrilateral, add to 180. Beautifully legible. There we go.